Okay. All right, so let's get started. My name is Jeremy, and I will talk a little bit about the state of debugging in JupyterLab. So we're going to start right away and look at the current tools we have for debugging Jupyter notebooks. So of course, I think pretty much everyone is familiar with print statements. That's the basics of programming. We don't know what the variable is. We just put a print statement. Here we have a for loop. We just want to see the value of j, put a print. That's super easy. That's super fast. And we get this visual feedback, which is really nice. But we're not able to break. We're not able to inspect anything. We're just able to see text. So if we want to use a real debugger, there are already some options like IPDB or PDB. And in Python 3.7, we can actually use the breakpoint syntax. So when I execute this cell, the execution will be stopped where the breakpoint is. And here I have the possibility to run a few commands to, for example, print the value of j, continue the execution. So now we do one more iteration of the loop. And I can do one more time this print j, and we see that the value has changed. And we can, of course, quit. And that's the basic workflow we have with such debuggers. So that's really nice. They are fully featured. But we still need to remember those commands or refer to the documentation to know what to do when we have this prompt. Which is why I wanted to also mention quickly this project called Pixie Debugger, which I think was initiated by the folks from IBM. And instead of just running it here, because I think it's only notebook available on a notebook, so let's do this. It adds a bunch of buttons, so you can have a proper UI for debugger here. So you can just continue step and see your variables on the side, and a bunch of other nice features. So let's continue with the other tools we have. So of course we can switch to IDEs like PyCharm or Visual Studio, but it's like switching environments. So we are like working with notebooks, JupyterLab or Jupyter Classic Notebook, and we don't necessarily want to switch over to a different tool, even though they are really great. They've been used for many years. They're super mature. So something in between that I wanted to also demo here is the Visual Studio Code cell debugging. So I'm not even sure it's actually released because it was just part of the insider preview mode. And again, I'm going to show you a little video instead. So maybe we can make that bigger. So here you see that you get some annotations that tells you, okay, now you can debug a cell or run it. And then you are able to use the VS Code debugger, which is already there, to be able to step in your code. But you probably saw too that we are actually looking at a .py file, and it's not a notebook. It doesn't really look like a notebook. We have this cell annotations, which is great, but still it's not like the true experience of debugging Jupyter notebooks. So what if we could have native support for debugging in Jupyter kernels directly? So we're going to look at a very complicated cell at the moment. So I just wanted to show you quickly what is happening under the hood when we actually execute a code in a notebook. So I can do that. I can do it several times. But under the hood, we have a kernel, and we can actually see the messages that are being sent over the network. So if I do this, we see that we have execute requests they sent on a channel that is called the shell. And if I expand the request here, we can see that the content contains the code that I need to execute. And we get a bunch of other messages on different channels, and one of them is the execute reply, which is going to give us the result, whether the execution has succeeded or not, as well as a new execution count. So this is the basics of the messaging in Jupyter. And the good news is that we now have 3 more messages to send and receive debug requests and events. So they have been added to the Jupyter client. They are now available on the documentation here. So this is a little glimpse at what it looks like. And we see that we only need to pass a content. So the body of the content is not specified yet. I will come back to it a bit later. But at least we have those 3 messages. So 3 new messages, but that means that we also need to implement it in a kernel. And fortunately, there is already a kernel that implements these new messages, and it's called SwissPython. It's a Python kernel. It's an alternative kernel to run Python code, alternative to IPy kernel. And all of this work has mostly been driven by Johan Mabil, who is also working at the QuantStack. And he went all the way from handling all of these messages, as well as adding a debugger to this SwissPython kernel. And I wanted to also show that it's not only one project, but it's more likely spanning a bunch of other Jupyter projects. So now we are really talking about having this as a standard in the Jupyter ecosystem, so that other kernels can also leverage this messaging and implement debuggers, for example, for C++ or other languages, R and Julia. All right, so you might wonder, like, we didn't cover yet this content thing. And so here we have the choice. We can basically send any type of value or any type of data. But we decided to go with something that has been proven to work and has been there for several years, and it's called the Debug Adapter Protocol. So this is the protocol is used in VS Code and also in other IDEs, such as TEA IDE. And this is fully specified here, so I'm going to show you what it looks like. So it's a protocol. You get all of the specifications you need to send messages and to get the replies, so it's really well documented. And this is just great. Working with protocols is just great. And basically, we only need to support this to be able to have a proper debugger working in JupyterLab. So a bit of more details on the way it works. There is another component called PTVSD, and this is the actual part that is able to talk the debug adapter protocol. So all of the messages we're going to send over the network from our interface here are going to be sent to the SwissPython kernel for now, and then to other kernels later. And PTVSD will be able to get those messages and be able to break in code or set breakpoints and so on. So another quick look at what it looks like when it comes to the protocol. So this is coming from the, again, the documentation for the debug adapter protocol. And we get this nice sequence diagram. And here, as a development tool, it's basically us, JupyterLab, like the people making the UI and UX for a debugger. And the debug adapter here will be PTVSD running in the kernel. And again, what's great is that we can actually ignore all of this part on the right and only focus on the left side. So if we want to make a debugger extension for JupyterLab, we only need to be able to speak the debug adapter protocol and basically just send initialize request, set breakpoints, and so on. And if we want to have support for other languages and other kernels, then there is nothing to change because the protocol is already there. So that brings me to what we have been working on in the past weeks, and that is debugger extension for JupyterLab. So a quick note on the extensions for JupyterLab. You might have maybe played with them already, and you get Git extensions, for example, and a bunch of other IDE-like features. And we decided to bring like a true debugging experience to JupyterLab as well. So it's under active development. You can find the code here. It's under active development, so we are still moving pretty fast. And it's mostly driven by QuantStack and 2 Sigma. And development at QuantStack is funded by Bloomberg, so we're really grateful for that. And so if you take the repo that I mentioned before, and you try to run it locally, this is basically what you will get. So the idea is really to bring these common interfaces that you see in other IDEs to JupyterLab, so you are familiar with a variable explorer, for example, call stack, breakpoints to be able to execute code and step in, step out, and so on. But before starting the work on this extension, we also made a quick prototype, and this is the one I will demo now, which is also using the debug adapter protocol, SwissPython, and all of the chain that I talked about before. But for that, we need to switch to the proper kernel. So let's do this. So now we are using SwissPython. As you can see, it's a regular Python kernel. Also has support for widgets. And one thing you might have noticed since the beginning is this little icon on the left side. So I can click on it, and I get this debug panel. So we have the possibility to look at variables and look at the breakpoints, but there is none for now. So let's go here. And let's say I want to see what is happening on line 3 and line 4. So I can just click on the gutter. I get my breakpoints. They are automatically synced here. I can also go back and remove them, put it at another line, or put it back here. So now that we have our breakpoints, we want to start debugging. So I'm going to click here. And now we are back here. So nothing happened, and that's completely normal, because we want to keep the normal user flow. So what the user does usually is do a control execute. So we're going to do this. And now we see that we managed to break. So we hit the first breakpoint, and now we get a glimpse at all of the values that are actually live in the kernel. So a bunch of them come from the previous cells because, again, we keep the same state. But what we can do is we can start clicking on continue. So this is really triggering a continue to continue the execution flow. Later we'll have the step in, step out, and all of these other common features. And we could, for example, look at the value of j, and we see that it's going to change every time we continue. And the nice side effect of this is we also get the prints one by one, so like we would expect. So we can continue like this, or we can also stop debugging. All right, so back to the widgets. I wanted to show the widgets because this could come handy. Sometimes we don't know exactly what is happening with callbacks and so on. So we could do the same here. We could put a breakpoint and then click on Start Debugger and then Control Execute. And we have hit a breakpoint one more time. And if we click here on Continue, we see that the slider is also moving. So now we are really stepping in the code. So we can continue like this. And if we happen to actually continue until the end of the execution flow, then we are back to the normal interface, so we can actually continue and not necessarily use the debugger all the time. So that's pretty much the current state. So this is again under very active development. We welcome feedback, and if you have any questions, just come talk to me or find other QuantStack folks here. And thank you very much.